All right, so here we're going to talk about work rates. This is still in section 1.6 and work rate problems. The rate of, if you think about this, it makes pretty good sense. If you think about the rate at which a job can be finished, right? So the work rate, trying to get myself straight. The work rate, that just is the amount of work you can do in some amount of time. So as far as the work, what kind of work are you doing? Well, I'm trying to complete some job. So you can do the job you're trying to do over the time, right? That's the work rate. So jobs over the time. So you can get into this right here, but I feel like it makes more sense if you just think about it like, so let's go to this problem, right? It says one printer can do a job twice as fast as another. Working together, both printers can do a job in 2 hours. How long would it take if each printer working alone, to do the job? So let's think about this real quick. One printer can do a job twice as fast as another. So basically, right now we know we got two printers. We got printer 1, we'll call it, and then we got printer 2, okay? One can do a job twice as fast as another. So what is the job? I'm not sure. We're just going to say one job for one printer takes, I don't know how much time. We'll just call it X. We'll talk about time. And we know it's hours because the job in hour. And both printers can do the job in 2 hours. So X hours, right? And then there's another printer and it can do one job in, twice as fast. So, really I'm going to say 2x because this one would be twice as fast as, this one. So one completes a job in, however many hours and the other completes a job in double that. So one of them is twice as fast as the other, right? All right. So working together, both printers can do a job in 2 hours. How long would it take each printer to do? How long would it take them working alone to do the job? So if we set this up, right, working together, well, when the printers are working together, I got my printer 1 working together, right, with my printer 2, right? That's working together. Working together, right there. Right? And they can do one job in 2 hours. Right? So let's get into that. So for printer 1, I'm going to say, instead of printer 1, I'm going to say 1 over x. For printer 2, I'm going to say plus, 1 over 2x equals 1 over 2. And now this is just a rational equation that we solved the other day. This is a simple rational equation too, so even better, right? So let me get my different colors out. All right, so first we can think about LCD, right? Least common denominator. Well, I need an x because my first one has an x, right? My second one has a 2x. My second term has a 2x. Well, I already have an x right here, so I just need a 2. So times 2. Now it's a 2x. I got that covered. And then my last term has a 2. Well, I already have a 2. So my LCD is 2x, right? So that means if I multiply everything by 2x, then my fractions will go away. So in the numerators, I got, 1 times 2x is 2x divided by x plus 2x divided by 2x equals 2x divided by 2. That's just me multiplying every term by 2x, right? All right, so I simplify things. I got 2 plus 1 equals x. Okay, that means 3 is equal to x. So what is x? X is the amount of time for the printer to do a job, printer 1, right? So there's printer 1, P1 does one job in 3 hours. So it takes printer 1 3 hours. And it takes printer 2 does one job in 2x, so 2 times 3, so 6 hours. So we got printer 1, which is the fast printer, and printer 2, which is the slow printer. All right, so hopefully that made some good sense to you. Let's try another one. All right. Filling an inlet pipe can fill Blake's pool in 5 hours, and an outlet pipe can empty the pool in 8 hours. In his haste to surf the internet, Blake left both pipes open. How long did it take to fill the pool? So let's think about it. The job is, we got the inlet pipe, right? We got two things happening. We got the inlet pipe, and then we have the outlet pipe. The inlet pipe, its job of, in this case, is filling. It can do one pool, and that is going to happen in 5 hours. Okay? Now we have an outlet, and its job is emptying, and it can do one pool, right? The same pool in 8 hours. All right. So he left both pipes open. How long did it take to empty the pool? So let's think about this. The inlet is working and the outlet is working, and it wants to know the time it takes to do, in this case, to fill one pool. And how long does it take? I don't know. X, right? X hours. All right, now they're working at the same time, but are they working together? Well, one of them's doing filling and one of them's emptying, and if they're working at the same time and they're one filling and one's emptying, they're working against each other. So this subtraction sign means working against one another. So no, they are not working together. They're working against each other. So if I say the inlet is one pool in 5 hours and I'm subtracting the outlet, which is one pool in 8 hours, then that's going to give me that's, if we leave them on long enough, eventually this is going to get filled up. And how long does it take to fill up one pool? So, LCD. Let's see, I need a 5 in there because my first term. My second term, I need an 8 in there, right? 8 is not a factor of 5, so 5 is a prime number. 8 is, 2 times 4 or 2 times 2 times 2, so it doesn't have a 5 in it. And then I need an x in there. So in this case, I need 8 times 5 times x, which is 40x. So if I multiply everything by 40x, right? Then I'll have 40x over 5 minus 40x over 8 equals 40x over x. Then I can simplify that. 40 divided by 5 is 8, so I got 8x. Subtract 40 divided by 8 is 5. 5x equals 40. So that means 3x is equal to 40. And then I'm trying to solve for x, so I divide by 3, and I have x equals 40 over 3, which I can say that's 13.33, which I could also say that's, if I'm thinking about, if someone says 13.333 hours, you might know what that is, but it's probably easier to say 13 hours, and then 1/3 of an hour is 20 minutes. So 13 hours and 20 minutes is how long it would take to fill the pool if you had the inlet pipe open and the outlet open. So kind of like filling the bath with the drain open, right? All right, hopefully that helps you with your work rate problem.